We'll now look at the method of partial fractions. So the idea, we know how to add fractions. We find a common denominator and then add the numerators. So the idea of partial fractions is to go in the opposite direction. We have a fraction and we're trying to figure out what fractions we can add to get this fraction. So we're going to look at three cases. We'll start with simple linear factors. So we're going to let f of x be equal to p of x over q of x, where p and q are both polynomials with no common factors. So if they do have something in common, we should go ahead and cancel it first. We also need the degree of p to be less than the degree of q. If the degree of the numerator is higher, we should look at dividing fractions instead. So we'll assume that q is the product of simple linear factors. And then our partial fraction decomposition will have a few steps. The first step is to factor the form. Like I said, this should be the product of simple linear factors, so we should be able to factor. We'll then form our decomposition by basically setting up a fraction for each one of these linear factors. We'll multiply both sides by the original denominator, and then we'll solve for these coefficients. So for example, let's find this partial fraction decomposition. So we start with factoring this denominator. We can factor out an x. That'll give us 3x squared plus 4x minus 4. So this is x times 3x, and then we also have an x. We'll have the 2's to multiply to be a 4. We'll have the outside to be positive 6x, the inside terms to give us negative 2x, which will give us the positive 4x in the center. So my partial fraction decomposition looks like x squared plus 4 over x, 3x minus 2, x plus 2, and this will be equal to a over x plus b over 3x minus 2 plus c over x plus 2. Next, we'll multiply this entire equation by the original denominator, x, 3x minus 2, x plus 2. When we do that, the left-hand side just becomes x squared plus 4. On the right-hand side, we end up with a, 3x minus 2, x plus 2, plus b, x, x plus 2, plus c, x, 3x, minus 2. So this should hold no matter what values of x we use. So we're going to use some ones that are going to work out nicely for us, like letting x be equal to 0. On the left-hand side, we'll have 0 squared plus 4. On the right-hand side, this becomes negative 4a. And then the b term and the c term will both cancel. So we see that a is negative 1. If I let x be equal to 2/3, on the right I would have 2/3 squared, which is 4 over 9, plus 4, which will be 40 over 9. You'll notice the a term will cancel, as well as the c term, so we're only left with the b term. So we have b times 2/3 times 2/3 plus 2. And once we work that out, we get 16 over 3 b. Or sorry, 16 over 9 b. Multiplying both sides gives us that b is 5 over 2. We can also let x be equal to negative 2. On the left-hand side, I get negative 2 squared plus 4, which will be 4 plus 4, which is 8. We'll see this will cancel both the a and the b term. On the c term, I'll have c times negative 2 times negative 6 minus 2. So negative 8 times negative 2 will be positive 16c. So c is 1/2. So my partial fraction decomposition, a was negative 1, plus b, which was 5/2, and then we have c being 1/2. So we have this partial fraction decomposition. Let's look at one more, and this time we'll actually take it a step further and integrate. So we can see that this denominator is going to factor into x minus 3x plus 2. So I get 3x minus 11 over x minus 3, x plus 2, is equal to a over x minus 3 plus b over x plus 2. Multiplying both sides by the denominator, x minus 3x plus 2, gives 3x minus 11, which is equal to a x plus 2, plus b x minus 3. Since this holds no matter what values of x we use, we'll start by letting x be equal to 3 in this case. So on the right I get 9 minus 11, which is negative 2, 5 times a, and then you'll notice the b term cancels. So a is negative 2/5. If I let x be equal to negative 2, on the right I get negative 6 minus 11, which is negative 17. And then on the right, the a's cancel, and I get negative 5b. So b is 17/5. So I end up with negative 2/5 over x minus 3 plus 17/5 x plus 2. So now let's try to integrate this. We can move constants out front, so I can move out this negative 2/5 and have 1 over x minus 3 dx. I can also move out the 17/5. So I have the integral of 1 over x plus 2 dx. So to evaluate these integrals, we'll do a substitution. I'm going to let u be equal to x minus 3. So du is equal to dx. That makes this first integral the integral of 1 over u du. So this will be negative 2/5 ln of u, or negative 2/5 ln of x minus 3. We're going to want to do something similar on the right-hand side. Since this is a different substitution, I'll use a different letter. We'll say w is x plus 2. Then dw is dx. So I have 17/5 times the integral of 1 over w dw. So that gives me 17/5 ln of w. And then substituting back, I get 17/5 ln of x plus 2 plus